Hey TechKnowStuds, in this video we're going to talk about marking. We're going to talk about it on a layer 2 and a layer 3 perspective and how it marks the frame and the packet so that other devices can also identify the classification and treat the packet and the frame accordingly. In this video we're going to go over marking the packet. Then we're going to get into how it marks the packet from a layer 2 perspective and how it marks the packet from a layer 3 perspective. Then we'll wrap things up talking about a trust boundary and what a trust boundary is. In a prior video, we talked about classification. And once we classify that data, then we can mark that data for other devices to use. An example of this is, let's say we have a phone that is on a phone network, a voice VLAN, and it's sending packets and it reaches R3. R3 is going to see that that's on a voice VLAN and then mark the frames and the packets accordingly. Then when it goes to R2 and R1, those devices just can look at those fields, look at the markings to see what classification there are, and then treat that traffic accordingly. In this case, since it's voice traffic, it will prioritize that to get to its final destination. So where does this mark the information for what category it is? Well, that depends on the protocol being used. So Ethernet is one example. Ethernet itself doesn't actually have the field, but a Ethernet 802.1q frame does. So we'll take a look at that a little more in depth, but it is a layer 2 and it does have a field that we can put in the class of service. It's 3 bits long for that. Wireless Wi-Fi has something within the 802.11 frame that it can use. It's a layer 2 and it's called a Wi-Fi traffic identifier or a TID. And it is 3 bits long. MPLS also has something. It is layer 2 and it's 3 bits long as well. Then we have IPv4 and IPv6. There is an old standard that has an IP precedence that's only 3 bits. We're going to talk more about that in our next video. And it also has a differentiated service code point, DSCP, which is 6 bits. So the main ones that we're going to actually focus on here is we're going to talk about this Ethernet frame or the class of service, and we're going to talk about IPv4 and IPv6 and this DSCP. So those are the two that we're going to talk about in this video. Here is an Ethernet frame, and with an Ethernet frame we have a header and we have a trailer. And by default the Ethernet frame does not have a tag involved in it. But when we are going across the trunk line, there is a tag that's included on here. And that tag has this identifier to it, has the VLAN ID, and the one that we're looking at here is this PCP field. So this PCP field has that class of service. It's 3 bits, and we can put in there a 3-bit representation of what is the priority of this frame. So what are those 3 bits? Well, those 3 bits are class of service. And this is the table that shows what those class of service values are and what are they used for. And when you have the lower class of service value, that means it's a lower priority. And the higher value means it's a higher priority. So we've talked a lot about voice, and we see that that's at 5 right there. You can see the binary. So it would actually have in that 3-bit field, it would say 101. And that represents 5 for that voice bearer. Video conferencing is 100, so that's a 4. Call signaling is a 2 and a 3. Medium effort means, yeah, we'll make an effort to do this. That's a 1. And a best effort is like, if there's time, if there's a bandwidth for this, then we'll get to it. And that's a 0. So that is class of service. And IP version 4 has this DSCP field. Together with the ECN field, these 8 bits is the type of service, or the TOS. So this is the type of service, these 8 bits right here. But the DSCP field we'll be talking about quite a bit here. That is these 6 bits right here. So when we're talking about identifying the class or the priority here, we're really talking in the IP version 4, when we're talking about marking it, we're really talking about this DSCP field. So we're going to get more involved in this DSCP and what it is. Then we have the IP version 6 marking, and that is the traffic class. So here is 8 bits that we have to work with here. And really what it is this is similar to the type of service that we see with IP version 4. So the first 6 bits of this is that DSCP field. The same designator that we will talk about. It applies both to IP version 4 and IP version 6. So we were going to get more in depth into that DSCP field. Now, one thing that we don't want to have happen is for users to plug in their device and then be able to send out information with their own DSCP information in there, their own packet with their own classification in there. Because what could happen is that if I had this set up on this demo laptop, this demo laptop could say, hey, I want you to prioritize my traffic over all other traffic. And that's going to be problematic, obviously. So we create this trust boundary. So the trust boundary is, what devices are we going to trust? So first of all, we probably are going to trust all of our routers at this point. And maybe we're going to trust this layer 3 switch is probably what we're going to do. And maybe this switch is trusted as well. But when it comes to this switch, maybe it's managed by somebody else, and so we're not going to trust that switch. So we create this boundary here of devices that we trust. And so these are the devices that are allowed to actually change that labeling, change that marking on the different frames and the different packets to identify the priority packets. Okay, there you have it. So what we talked about is QoS marking. We talked about how it marks both the layer 2 and the layer 3, and it uses that DSCP field to establish some sort of marking, classification, some sort of priority with it. We also talked about what devices can change that DSCP field, what can actually mark it as being priority. And those that fall within there, that's a trust boundary. So we create a trust boundary of what are we going to trust from when it comes to this DSCP marking and this layer 2 marking.